All right, welcome to class for Tuesday, May 5th. So it is Taco Tuesday and Cinco de Mayo, and we're all trapped inside because of a Mexican-sounding virus, which, you know, it's not, but it sounds like it. So anyway, it's an adventure of life. So for today, here's what's on the docket. So Sean is going to, let's see, is Cindy here yet? Nope, no Cindy yet. Okay, so Sean is going to tell us a little bit about scikit-learn and some of the things that one can do with scikit-learn. And then we need to talk briefly about final presentations, and that's pretty much it for today. So so let's start off with a little bit of machine learning.
Alrighty. Morning, everybody. Dr. Nelson, could I get the screen share?
I just turned it on.
All right. Let's see. I think that's what I want. All right. So can you all see me? All right. Can you all see my screen?
Yes.
All right. So we're going to talk today about scikit-learn, which is machine learning with Python. And so scikit-learn is, well, pretty much it's able to take a lot of data and really take the meat and bones off of it. It's really able to dissect data, and like I like to think of it as kind of the opposite of pandas, where pandas makes it really easy for you, the user, to view your data. Scikit-learn makes it really easy for your computer to use all of your data. And so with this little tutorial, they talk about machine learning. We're going to talk a little bit about matplotlib, and I'm only going to cover, down to including principal component analysis, because that was what I did over the summer. It's just principal component analysis. Lots and lots of principal component analysis. Anyway, so loading your data set, they talk a little bit about that. So pretty much with using data on scikit-learn, you have two types of data sets. You have your training data, and you have your test data. And a lot of the data sets that they have, well, usually most people start from scratch, but apparently UCI has a machine learning repository. Oh, it takes me. Oh gosh. So apparently it does a lot of this stuff, but it is through UC Irvine. So if anyone is interested in that, I'm going to UC Irvine by all means. But pretty much, so what this tutorial does, it loads the dataset digits into scikit-learn. Digits is just something that comes with scikit-learn, or that comes with Python, and in reality, it's just a I completely lost my train of thought. It's a Python package. Datasets is a Python package. So we're going to go over here, and it has this little on-screen Python thing. So we're going to
let me chime in real quick and interrupt you. So I would encourage everybody, go to the website. You can actually run these little snippets of data they have a Python shell that runs in their web page. So I'd encourage everybody to just do that while Sean is doing it and talking through it.
So it didn't print anything. Um, but it did run, apparently.
That's interesting. Try clicking it again. Mine actually spits out numbers. Does anybody else's actually spit out numbers? Is anybody else alive?
I'm about to find out if mine spits out numbers.
I'm pulling it up right now.
I just put a link to it in the chat if you didn't have it up.
Yeah, I have numbers spit out.
Oh, hey, I finally do have numbers. Yay. Yay for numbers. Okay. So now you know how to load in data sets. It gives you apparently a lot of, or actually I think this is all just describing it gives you a dictionary of you have your data, and assigned to that data you have an array of various numbers. So that's what digits does. So down here it talks a little bit about pulling from a pandas repository. So say this is data that you have the spreadsheet data and you're wanting to put it into a machine learning. This is where you would use it. So we're going to import pandas as PD. PD is, as we know, the common abbreviation for pandas. So now we're going to run this, where it's taking, it's reading CSV. I'm not quite sure what that is, but it's how Pandas is able to read in from a data site, and you can tell that it's a training training data that we're learning or that we're feeding into it because it has a .tra. It should say up here a little bit that hold on, let's talk about. Oh yeah, it'll show you in a bit. Oh yeah, right here. Split up in a training set and a testing set. The TRA is a training set, and the TES is the testing set. And so when you scroll up a little bit, I don't know why it's only giving me like the top 2 lines of numbers, but that's how it is this morning.
Yeah, mine's not doing that. Is that mine gives me a whole bunch of stuff. Do other what is everybody else getting?
This is me just scrolling. But anyway.
And anybody else? Yay, nay, maybe. Hello? Hello?
I'm being very stupid about having the Zoom window and a window of my web browser open at the same time.
But anyway, so this is how you would show off or import load-in data from using Pandas. Pandas works with scikit-learn. Scikit-learn works with Pandas. It's kind of like NumPy and SciPy. They all just work well together. So now you get to exploring data analysis. Hold on, I have a little bit of chat. Oh, CSV means comma separated values. Thank you, Cindy. And I think I got something similar, Bjorn, but it is. But my computer is not wanting to cooperate this morning, so. Oh, look, 3823. Anyway. So exploring the data, exploratory data analysis, trying to move my Zoom thingy. Okay, first starting out the data set, pretty much what you guys, the way that machine learning in this class should work is we're able to give a data set of, we're able to show, so for traveling salesmen, what they generally would do is show how to go from one planet, or tell each point how to go from one planet to another. And it will then, if you give it enough test variables, the more tests you, or the more training that the machine learning has, generally the better it runs. Or at least that's how much I know.
So I'll chime in there that what really machine learning is doing the opposite of modeling. Machine learning is trying to use lots and lots of data to understand to create a model for the data. So modeling or simulation is where you have a model, right, physics, and you use that model to simulate what will happen. Machine learning is the opposite process. It's taking what actually happened and using it to create a model that you can use to predict something else, right? So in this case, what the data is a bunch of scans of digits, individual characters, right? And somebody went through and scanned in a whole bunch of handwritten characters as very simple arrays. So I think they're like 9x9 arrays of values. And they're just simply a value that corresponds to how dark on average that particular pixel was on the block around the digit, okay? And so what we have is a bunch of data. We want to create a model that could be used to predict, if you give it a scan of an individual digit, a handwritten letter, right? What letter is that? Does that make sense? So machine learning, to really emphasize, machine learning is the opposite of simulation. Machine learning is saying reality has provided us with a big block of data. Now we want to make a model that explains how that data came to be so that we can predict something in the future.
Alrighty. So this next bit of code is how the user is able to gather more basic information on the data. So pretty much with any digits data, you have keys, which are, hey, I know that at this point it's going to be like this because all the other times was like that. So keys is which keys you have available to already get to. So keys is like what you already know. Then there's the data, and then you also have your target values, which is from your which is from the training sets, and they'll often have a description. So when you run this code, And I really wish it wasn't doing this, because this would be really cool to see. The only other option is doing this on Python, and my computer would cry. So then it goes on to talk about,
So Sean,
Go ahead.
why don't I actually run this over on Python and you can kind of talk through it? That might work better, because it would. I mean, I think this would work a lot better if people can see what it is that we're doing.
Mm-hmm.
So let me hold on one second here. Where did it go?
Stop sharing.
Okay. Okay. So we're using the thing from Pandas, right?
Yes.
All right. Because I'm going to have to let me start sharing. I'm going to have to piece together the code, because this is all running. So these little Python shells are all talking to each other, I think. So let's see here. Okay. Okay. So I'm going to see if I can keep up, but this is this is what we've got. So the first thing it printed was digits, right? Which is digits is a data frame. It's a Pandas data frame, which you can think of like as a spreadsheet, right? And if we look at it, it is this enormous thing, right, that has a whole bunch of values in it. Okay, that's what digits is. But digits, because it's a Pandas data frame, it has a number of pieces. Now it's yelling at me an error that it has no object data. I think it should have an object data. Interesting. Why don't I have a data? Well, keys worked. Okay, so keys. Okay, so what is keys? Let's print a couple of blank lines here. Okay, so keys printed that.
So keys is like the top row of the data.
Okay. So it's just representing that there are 64. Oh, it's an 8x8 grid. That's what it is. It's not a 9x9 grid. It's an, oh wait, but there's 65 because it's 0 through 64. I'm confused as to why there are 65 things there.
Because it starts at 0.
Right, but I thought these were supposed to be individual images of. So why are there 65 of them? How you couldn't make a grid out of 65?
It's because it's 3,823 rows by 65 columns is what what digits is.
Well, I understand, but why is it? Why is it 65?
I think that would probably stem from the URL, because you're
Right.
taking the comma separated values from archive.ics.uci.edu/ml/
Okay. I guess what I'm saying is I don't understand the. Hold on one second. I don't understand what this data set is, I guess. All right, well, let's just keep going.
Alrighty. So we talked about gather. Oh wait, hold on. Shall I go back to sharing my screen?
No, here, let me do this actually. Let me just share the whole screen and so you can see both things at the same time. Okay, so you just tell me to scroll up or down.
Okay. So I'm just below the where we just had the digits.data, digits.target, digits.description, that sort of deal.
Uh-huh.
Just move from there. And so next thing that you can double check is your type of data. So pretty much with run CSV, that will just have the data and not any of the names. So in order to see what each column is, you would do header tail to inspect it. And sometimes it's just easy to look at look at the data folders, because that's usually one of the easy. Know your data. Understand the data before you present it or before you use it. And if you don't know your data, you can use header tail to check to see, oh, what are the columns or what are the columns representing?
Okay, I'm sorry. Maybe I better go back to just running things in here, because when I run them on mine, I get all kinds of weird stuff. So let's just come back over here. All right, so let's look at this. Keys. Okay, so keys, this is what I was expecting to get. Keys gives me the keys to the dictionaries, right? So it says that there are fields called images, target names, description, target, and data. Okay. And then when you actually print the data, it prints out this gobbledygook, which is intelligently, truncated. When I print out the target values, right, that's just telling you the answers, right? A person went through and said, oh, this image looks like a 0. Let's see if I can, so let me print digits dot data sub 0. Okay, so that is what is actually in the first entry, right? And what they did is they've made an array of values that corresponds to, they took an image of a character, right? A digit in a number. And they just said, okay, if it's really dark in that block, we give it like a 15. And if it's a little dark, we give it a 13. And if it's kind of dark, we give it a 1. And if it's not dark at all, we give it a 0. And that combination of things will lead to an image that looks like a whatever, let's see, whatever's up here in targets, right? A 0. and the next one's a 1, and the next one's a 2. So does everyone, I'm sorry, we got a little lost here, but does that make sense to everybody? What's happening here, what this data actually is? Okay, so, and then it's also showing you that this thing also has a description, and it has, and in that description, it tells you about this thing, right? So for example, you know, it says optical recognition of handwritten digits data set, and it has notes. Each one is a 4x4 image of an integer, pixels in the range of 0 to 16, right? All right. Okay, sorry, keep going.
No worries. So the next part that I think is really critical is the visualize your data images with Matplotlib. Because what's after that is just like, oh, here's how to check your data again and check your data again. And so you go with scroll down to visualize your data with your data images with Matplotlib. Right there. So pretty much this chunk of code right here kind of tells you a lot about how you're going to like how to plot the data. And so they have the
I'm going to try something. Really gone so keep going. Sorry, keep going.
I haven't quite fully gone into all of this, but it looks like it's this forms an 8x8 or a grid of 8x8 subplots. Do I have that correct, Dr. Nelson?
Yes.
Okay. And it then iterates over for each one. It iterates, oh, right, this is what it should be at this position, and they do a color plot. So, or they use image show. Okay.
All right. So sorry to interrupt again. Okay. So I've got this thing working now. So I don't know what the problem was, but when I was getting the data from the web off of the web, it wasn't loading properly. But now that just loading it off of from scikit-learn, it seems to be loading just fine. So now it is all in the right thing, and you can click on it and look right in your variable explorer and see that it's got description, data set, images, target names, right? Things are listed as 8x8 arrays, which means now we could come over here and do import matplotlib.py plot as plt. And we could come down here and we could do IM show on digits dot data sub 0, comma. And this should pop up a window. Maybe.
Could you by chance make your editor full screen?
I can make it bigger. Let me make the text bigger. Okay, I grabbed the wrong thing. Data is, oh, I should do images. There we go. And there you go. That is what happened if you scanned in a handwritten 0, right? And of course, your eye looks at that and says, oh yeah, it's a 0. It's like a circle, right? I mean, it's weirdly colored, but it's a circle. And it'd probably look even better if I did something like, let's see here. Is it color or CMap? If I make it gray. All right, where do we go? There we go. There you go. Now it's just an inverted thing, right? But it looks like somebody wrote a 0, and this is what happens when they digitized it. Okay, so we can actually make images. Wonderful.
Mm-hmm.
All right, keep going.
So the rest of it gives a very detailed, like, step-by-step of how to visualize the data using Matplotlib, and it's a pretty good description. I recommend everyone look through it because I have, and it's helped. But yeah, it just kind of scrolls down a little bit. It shows different methods of pretty much how machine learning will eventually, like how it does the, like I think if you were to run the chunk of code up here, I think it would give like a series of, numbers that look like they might have been drawn in. I think Dr. Nelson is showing it on his screen right now. And then, oh, yep. Well, I'll be danged. That looks cool. I realize I've been giving you guys all a large shot of my forehead, and I'm very sorry. Or let me rephrase it. A very large shot of my 5 head, and I'm very sorry about that. But anyway, moving on. The last part that I'm going to cover today is the principal component analysis. And this is something that I know a little bit about because it is what I did my summer research project on. So with principal component analysis, so it talks about it down here that you have 64 features, but that pretty much gives you 64 dimensions of what you're working with. So it's when you're trying to describe an object that has a bunch of different features. So in my case, I was dealing with different different galactic properties, such as the property. For those of you guys that remember my talk, it was the properties of magnesium 2, of the nearest, its local density, of a galaxy's metallicity. Pretty much figuring out all of these different things are used to describe this galaxy. And now we need to find how are these related to each other. And that is where principal component analysis comes in. Because visualizing data in 2 dimensions is very easy, and visualizing data in n dimensions is not easy. So it goes on to show this little code snippet of showing how to do a PCA. And it talks about doing it with 2 components. So when it is run,
Doesn't like that. Let's see. I must have missed something.
and pretty much what the principal component does And I'm reading this off the website because this is the best description of it that I've been able to come up with, and I've given the presentation on principal component analysis at least half a dozen times. It's a linear transformation method that yields the directions that maximize the variance of the data. So pretty much when you're trying to figure out how varied is my data, this will help tell you. And the more spread, the higher the spread, the more variability.
It's in decomposition. Okay. Sorry, I was just figuring out where that is. Decomposition, import. Oh, what is it not like that? Well, nuts. Okay, let's get this far. What? Okay, apparently my version of scikit-learn isn't compatible with my version of SciPy. It's always something. Well, let's see if I just run it in the web page what it does. Okay, it output a bunch of stuff. Let's put a space there. Yeah, I got it. Okay. All right, so we run the thing, we run the principal component analysis, and it generates a list of principal components, right? And okay, 2 components. All right. Okay, now I'm confused. What is this thing doing again?
So which part are you at? Are you at the, hold up.
So this piece on my screen here.
You can easily apply PCA to your data with the help of scikit-learn. Okay. So what this is doing, it's creating a random PCA model that takes in 2 components.
Which
so
2 components?
I think it's just giving you a random or just 2 that you're wanting.
But isn't this based off of our data? Our data has 64 components. Okay, we may have to come back to this one because I've managed to confuse myself. Okay, so let's take a time out here because I think we've kind of got wrapped around the axle at this point. So here is your homework for Thursday. I want everybody to take a look at this, get it to run on your own machine. I'll figure out why on earth it's not running on mine. And we'll get it up and running, get it all happy. And then let's come back on Thursday, and I want everybody, not just Sean and Cindy, but everybody to take a look at this and see if you can figure out what this principal component model is doing. It's clearly spitting out a whole bunch of things, right? But what are these things? Why do they all have two numbers? What do the two numbers mean? Okay. We clear?
Mm-hmm.
Mm-hmm.
All right. And then we'll come back on Thursday. Okay, thanks, Sean. Good job. There was a lot of stuff, and we had a lot of technical problems, more technical problems than we've had in the past. I kind of thought that thing where it ran in the browser would work really nicely until I actually started running all the bits and pieces of code as you were doing it and realizing that it actually makes it hard to see what's happening.
Gotta love technology.
All right. Okay, so we'll come back and talk more about that one on Thursday. And Cindy, if you want to pick up after the principal component analysis piece and look at some of the pre-processing and the k-means model, we'll go from there. I don't think we'll be able to get through the support vector machines, but all of these are the same kind of idea. What we're trying to do is we're trying to reduce a complex data set into something manageable, right? And something that we understand. In this case, what we want to be able to do is feed it a new image of a digit and have the computer tell which one it is, right? So basically what this thing is doing is it's creating a handwriting recognition machine, right? Something where somebody can write a number on a piece of paper, scan it into a computer, and the computer can know what number they wrote.
Dr. Nelson, I think I know why it's the number of components. It's because that's how many dimensions your plot will be.
Oh, I see.
So, and components equals
It's
2.
taking the top two.
I think
It's taking the two biggest components and then projecting data onto them.
Mm-hmm.
Cool. That makes sense. Good, good. All right. So anyway, we'll come back and look at that a little more later. And I'll get it working up on my version of Anaconda, and we can actually play with the thing. So, okay. The one other thing we need to talk about today is we need to talk briefly about poster presentations. So for the final, our final is officially, for some reason, our final officially got scheduled as being asynchronous, meaning that we don't have a formal final time slot. I've requested that we get the final time slot that we all expected to have, which is Tuesday from noon to 2. Does that work for everyone? Or let me state it the other way. Is there anyone that does not work for that conflicts with another final?
As far as I know, it doesn't. I also need to look up my finals.
Okay, so that's your other piece of homework. I need everybody to come to class on Thursday knowing whether or not they have a conflict with doing our final Tuesday from noon to 2. If we don't have any conflicts, okay, so I've got some thumbs up and works for me. So some of you are okay. Okay, but everybody, if you don't know, check. And we'll go ahead and just assume that time slot works until I hear otherwise. What I'd like to do, we've got a 2-hour block. I don't think we need that much time, but I'd like to give everybody about 25 minutes to present their projects. And you can do that however you like. If you would like to, you can present your posters. You will probably have time to present more than what's on your posters. So if you have some additional things that you've worked on since your poster, or stuff that you wanted to put on your poster but couldn't, or just, other things, that would be great. You're more than welcome, if you would prefer, to reorganize it into a slideshow, like a Google Slides or a PowerPoint. You can do that. This is really sort of free form, but shoot for about 20 minutes or so. That'll give 5 minutes for questions and discussion. We're all fairly familiar with each other's projects in here, but it'd be nice to be able to have some time for questions and comments and things. And then the other thing is, as far as grades go in this class, I don't really know how to, I mean, I told you this at the beginning. I don't really know how to grade any of you. You've all done fantastic work. I suspect what I'm going to do is just give you all A's. But so the reason I'm telling you this is, don't stress out about the grades in this class. You're in good shape. You've all done a lot of good work. Well done. Okay. The last thing I'll say is that I'm still planning on meeting with the Canopy Wave group about 2 o'clock today, and the Traveling Salesman or Sales Turnout group about 3. And yeah, I think we're good on other than that. Any other questions, comments, concerns? Okay. Well, I'm going to go ahead and stop the recording.